Thanks, Nick. That was pretty impressive. I used to go to a lot of music festivals, and I feel like the first slot at the music festival is not the best slot, but I'm happy to be opening up for Debbie. So thanks for being here. Thanks to Tara, thanks to Tina and all the organizers. I'm so excited for this week. Before I jump into my talk, I really want to just take a minute to recognize all the colleagues that worked with me to develop these tools over the years, including those in my own lab, especially Claire Phillips and Rachel Bashiri, and those at our partner institutions, including USBI, AFT, Oregon State University, Washington State University, and Cornell University and New York Soil Health. There's strong value in having so many motivated, creative people on our team, and we just could not do this without everybody's input. So if you've been to one of my talks, you've probably heard me talk about the hype curve or the technology curve that really describes how adoption of any technology happens. And I'm just going to take a really quick moment to walk through this. So when a new technology emerges, there may be a lot of immediate enthusiasm and hope that that technology is going to revolutionize agriculture or whatever the industry is. And everyone gets really excited. And then this is called the peak of inflated expectations. And soon after you get there, people start realizing that maybe it's not the silver bullet everybody thought it was, and you fall into the trough of disillusionment. Which sounds awful, but really that just reflects that the technology has not matured yet, right? We need to have more studies. We need to understand how that technology can be implemented. But as we learn more, as we move through this slope of enlightenment until the technology is ultimately adopted, we reach the plateau of productivity. I'm not really sure where biochar is on this slope, but if I had to guess, I'd say that we're somewhere in this slope of enlightenment. So today I'm going to talk to you about how we can move through that slope. And I don't think the answer is more studies. I'm not saying we don't need more studies, but we have 40,000 published papers on biochar. Last year we had over 7,000 papers published on biochar. If you don't want to do that math in your head, we would have to read 22 papers a day to keep up with the literature. And that's really overwhelming. So I think, I think that we need maybe something else, but we are getting better. So according to the Global Biochar Market Report in 2021, we had $55 million as a global industry, and that grew really quickly to $330 million in 2023, which is certainly promising. You can see most of that was in North America. So total megatons was about 352,000. I'm going to do some quick math here. If you think most of that was in North America, we're looking at maybe 175,000. 70% of that was in agriculture, so maybe 125,000, which sounds like a lot. But if you were to spread that all over the croplands across America, and this is a map of croplands in America, that would cover an area about the size of Chicago. So we have a long way to go and a lot of opportunity to put biochar in the right place. So what is going to spread what is going to grow our market? What's going to allow us to expand the market? Well, what I would say is that what we need to move from the trough of disillusionment to the plateau of productivity is tools for farmers to understand when, where, and how to use biochar. I'm guessing that most of you here know that biochar is generally good for soils and crops. It provides several environmental, several fertility, microbial, and plant benefits. But we also know that biochar is not a silver bullet, and not every biochar can provision all of these benefits at once. So I would argue that one of the main barriers to the adoption of biochar-based technology is the very thing that we think makes biochar so cool in the first place, which is that biochar is tunable, right? Biochar properties depend on the feedstock and the pyrolysis conditions under which it's made. So here's just a little photo that I took of some biochars we had in the lab, and you can see they're really different, right? They have different particle sizes depending on how they were cooked, and then again, depending on how, if we just look at the seed waste biochar and how it was produced, when it was produced at a really, a medium temperature, we had a lot of carbon capture. This little circle over to down at the bottom shows proximate analysis. So that black part of the pie chart is stable carbon. The green part is volatiles, and the gray part is ash. But if you cook it a little longer, you can see that those volatiles will move to ash at this temperature, and that has a really big impact on how it reacts with the soil. So if we look at the more ashy seed waste biochar, you can see it has a lot of liming value, or sorry, a lot of fertility value in terms of P and K, whereas the one cooked at this more medium temperature has a lot more stable carbon. Again, the ashier biochar has more liming value, while the other one has more carbon. And so this has direct consequences, right? So if your goal is to add carbon to the soil, you would want to choose this very black biochar. If your goal is to add nutrients and liming capacity, you would obviously make a different direction. And so when people call me and they say, hey, Kristin, how do I apply biochar? And I say, well, what are your goals? What are you trying to accomplish with applying biochar? Because not every biochars are not the same, and farmers don't always have the same goals for their cropping systems. And so what's important is that you identify goals, find a biochar that can meet those goals, and then find a rate that meets those needs. And if you're familiar with the principles of applying nutrients, this might sound a lot like the 3 or 4 R's, right? The right rate, the right place, and the right source. These are really important for correctly using fertilizer, but using biochar to improve soil health requires very similar thoughts and frameworks. So to help implement this framework, we developed the Pacific Northwest Biochar Atlas. And this is a tool that can help you find a biochar that's right for you, right for your soils, your crops, and you do this by entering in soil data, selecting a crop, identifying soil deficiencies or crop deficiencies, and finding a biochar that can meet those needs. The tool's available at pnwbiochar.org. We originally created this tool in 2017, and this tool is available for the Pacific Northwest, specifically Washington, Idaho, and Oregon. However, in 2025, we have expanded this now to the entire United States. So there's 2 different versions that are available online right now. We've got sort of the fancy schmancy Pacific Northwest biochar version, and then we've got the National Atlas. Today I'm going to spend some time on the Pacific Northwest version to just walk you through sort of the thought behind it, and then I'll briefly show you the beta version that's available for the national study. So, let me come back. Oh, we're here. So both tools use the same 3-step process. Step 1 is gathering information about your crop, gathering information about your soil, and inputting it into the system. Step 2 is using that information to set some goals for your biochar needs. And then step 3 is figuring out what rate, what kind of biochar, and then estimating those benefits. So I'll just walk through those steps. The tool, as I said, requires soil and crop data. For the Pacific Northwest version, you can either get baseline soil data through a Google Map interface, or you can enter that information in from a soil test. Once you enter or query data about data about soil health, specifically carbon, fertility, pH, and soil texture, you can move on to step 2, which is determining your goals. In step 2, you're going to take this soil analysis and you're going to enter it into the Property Explorer in the Biochar Atlas. And then using those data, it'll walk through a couple of different things. It'll tell you how high is your carbon? How does this compare to carbon within your soil type, within your cropping system? It'll tell you whether it's low, high, or medium. It'll do the same thing for soil fertility, but of course soil fertility is really based on what crop. So within the Atlas, you can choose over 40 different crops. That changes a little bit at the national level. And then it'll also tell you about acidity and your soil texture. Using this information, saying if your soils are low in SOC, low in nutrients, or not at the right pH for your crop, you can choose 3 different biochar goals around carbon, water, nutrients, and also around some environmental variables. Then using a ranking system, the tool will query our database of biochars and tell you which ones meet your goals. So here are the goals. Again, sequestering carbon, increasing pH, and increasing water were the ones that I chose for this demonstration. And you can see that here it tells me that, a biochar made from Oregon White Oak will address all three of those goals. And so when I go to the next step 3, I can choose a biochar and a rate at which I want to apply it, and it will tell me at different rates, 0.5 to 10 tons an acre, what sort of liming benefits, nutrient, and carbon benefits I can expect. And I'll just zoom in on that just a little bit. Okay. So there's also a cost-benefit analysis tool within the Biochar Atlas. So you can put in how much your biochar cost, what your expected increase in yield is, what your expected offset is for, say, P and K or lime, and it will calculate a 5-year budget for you. And you can discount this in future years as well. So one of the problems with this tool is that it really expects there to be an increase in farm income based on applying biochar. And we know that yield is really unpredictable. So if I can't go to a farmer and say, if you put down 1 biochar, 1 acre or 1 ton of biochar per acre, we're expecting a 10% yield increase. It's just, we don't have the theoretical framework to make that sort of predictive promise. And so one of the problems with this is that this cost-benefit analysis tool has a proposition value that's based on yield. However, in 2023, the National Resource Conservation Service released Conservation Practice Standard 336. Y'all may have heard of this. This is the USDA NRCS Conservation Practice Standard 336. It's the technical foundation for helping farmers adopt conservation practices around carbon-based amendments, including biochar carbon, biochar compost, mixtures of biochar and compost, and other carbon amendments. This is really cool because it provides both cost share and technical assistance for applying biochar or these other carbon compounds onto farmlands. And it really is cool because it changes the proposition of biochar from yield to conservation practices, which we know that biochar can accomplish, right? We know that when you add biochar to soils, it improves soils. And so Conservation Practice Standard 336 has now been adopted by 47 states. The only ones that are not, have not adopted the practice are the Dakotas and Alabama. So if you're interested in this, the priorities for implementing this program vary state to state, and so I would encourage you to reach out to your NRCS state conservationist, agronomist, or your local county-level conservation planner to learn more about 336. Just want to tell you a little bit more about it. The soil carbon amendment, again, it's a conservation practice standard that helps producers address resource concerns associated with the loss of soil health, primarily related to soil organic matter, sequestering carbon, improving soil carbon stocks, improving aggregate stability, and improving habitat for soil organisms. Again, this practice provides technical consideration in the application of carbon-based amendments, including the ones that I mentioned, compost, biochar, and other amendments that meet the requirements outlined in the practice standard. So if you have questions around this, I'm more than happy to spend some time with you during the break or any time over the next few days. So the Biochar Atlas is being used by NRCS to implement 336. So as I mentioned earlier, the decision support framework that I dived into earlier is now available throughout the United States. It's available at the web address listed below, or you can go to pnwbiochar.org and just follow the links to the National Atlas site. I do want to highlight some improvements to the tool. So with the National Atlas, we have nutrient requirements for the top 10 crops in every state. And if your crop is not listed in the Atlas, you can enter in your own nutrient requirements, which is pretty cool. All the biochars that are listed in the Atlas are now commercially available or commercially approved, commercially produced. So you can actually buy the products that the Atlas recommends, which is awesome. And there's a function that can help you find biochar in your state. Now, I will say one of the problems with the Biochar Atlas is that it's not as fancy as the PNW Biochar Atlas yet. We'll be working with USBI over the next year to find someone who can really expand this and make it pretty on the website. So I do want to warn you that this is the beta version, and there's lots to do in terms of bells and whistles and usability. But I'm excited to present it to you today. Okay, again, this is very similar to the PNW Biochar Atlas in that decisions still require you to input data about your soil, choose a crop or input crop requirements, and put in a zip code. Once you do that, it will interpret the input, list biochars that are nearby, and ask you to identify goals. We've limited the goals a little bit around nutrients, lime, organic matter, and water retention. So there's a more limited set of goals, but once you identify them, it'll give you the options that are best for each goal. So here we chose sequestering carbon, lime requirements, and P requirements to choose biochar, and then it'll rank those at for the best one for the time. So you can see that ranking, how that worked out here. And then from there, it will tell you how it expects those biochars to behave in soil. For example, here, a 5-ton per acre application will provide 1.5 tons of liming, liming equivalent to nearly 4 tons of soil carbon. So understanding that this is a very beta version of the National Biochar Atlas, there are improvements that are on the horizon. I would love it for you all to go to the National Biochar Atlas, check it out, and tell me why it's terrible and how we can make it better, because that's the only way we're going to improve this going forward. So please, over the next few days, check it out and take a look at it. Again, we're prepping to send this for web development, and it'll include several new functions, including a function that will allow you to input your own biochar so that you don't rely on our database of biochar, so you can understand how somebody else's biochar might react with your soil. And it will have a mapping function similar to one on Pacific Northwest Biochar Atlas site, and it will allow you to evaluate multiple amendments. So if you have a compost biochar mixture you're interested in, you can evaluate that as well. Because we have a need to evaluate multi-amendment blends right now, I just want to point out that there is a spreadsheet available on the PNW Biochar Atlas website. This is being used right now by conservation planners all over the country to implement 336. This tool will essentially tell you if an amendment qualifies to use the practice and does it provide a benefit. So if you're thinking about using 336, I encourage you to run your biochars through the calculator, see if they qualify. And I don't have time today to walk through this, but I will point out to you that it's available on the pnwbiochar.org. There's a whole page of tools to implement 336 on that site, and that's where you can find the amendment calculator. We do have additional tools that are available on the website, both for implementing CPS 336, but also just for general use of biochar. So we spent a lot of time since about 2021 putting together fact sheets. This was done in collaboration with USBI. There's probably 6 or 7 of them that are available that are kind of tuned towards agriculture, including how to apply it, a little bit more about the 3 R's we talked about, interpreting biochar lab reports, and so on and so forth. So I encourage you to check those out. Rachel Bashiri, who was a master's fellow in my lab, she put together a 42-page list of FAQs around biochar, and so this is also really helpful to provide for sort of people who are not familiar with biochar. And again, all of these are available on the 336 tools website on the Atlas. So just one more plug that your input is really needed to make these tools as flexible and as useful as possible. So please, go check them out on the pnwbiochar.org page and get back to me with how you think we can make them better. And if you would prefer to email me, my contact information is right there. The best part of my day is working with stakeholders, and so if you have questions about how to use these tools or how to use biochar in your system, I'd love to have a conversation, so please reach out. And with that, I think I have a few minutes for questions. Mayo?
Kristin, is this related to the web soil survey on USDA soil? Are these that biochar suitability index? I use it a lot.
So the biochar suitability index, so what Mayo is asking about is for those that are not soil people, there's this thing called Web Soil Survey. And it's available at Web Soil Survey. And what you can essentially do is go in there, outline an area that you're interested in, and once you choose that area of interest, you can go in and under the soil health tools, it will say, how do we predict that this soil is going to respond to biochar addition? That's all based on a paper that came out of a lab that Debbie was in for her PhD work at Iowa State. And it's really based off of whether or not the soil has low amounts of soil carbon, acidic soils, and then it asks some other questions about whether it's going to pond or is it on a slope, asking questions like that. And based on those kind of dynamic soil properties and inherent soil properties of the soil series, it will tell you whether or not the biochar is expected to respond good, poor, or you should not apply it. This is not related to that, and I'll kind of say I love the tool. I think it's really great, Mayo. It's a really good first look, but the problem with it is that it's all based on soil series. And what I can tell you from years of working with farmers and going out to a field and taking a soil core and looking at it is that oftentimes decades of management from farming has a huge impact on what those soils look like. So the pH is probably not what the tool predicts. The soil carbon is probably not what that tool predicts. And so I think it's a really good first look. I think if the tool tells you on Web Soil Survey not to apply it, the first question you have to ask is why? Is it because it's a slope? Because if it's on a really big slope, you probably shouldn't be tilling or applying biochar because there's erosion problems. Is it because there's ponding? Well, probably putting biochar on a bog is not your best bet either. So, but if it's a pH problem, if it's a soil carbon problem, I would definitely look at your soil test and sort of take what Web Soil Survey says with a grain of salt. I think the NRCS is planning on integrating these tools eventually, but right now they're separate. Yeah, right now they're separate. So that was a very long-winded answer to your question, Mayo. I do not know the answer to that question.
I know a lot that is applied. I was just curious if you don't know.
Yeah, I don't have the answer to that question, but I can. It's quite a bit. I mean, it depends what state you're in. So in Oregon, and if you want later in the week, I can get you actual numbers. I should have looked this up, but. It depends on the state. For example, in Oregon, we've had very few farmers that have been able to implement 336. Same thing with California, very low amounts of applications. But in the South, there have been quite a bit. So in the Southeast, there's been quite a bit. So I think it varies state to state, but I'll get you a better answer, I promise.
You say applications or actual awards?
Actual awards. Yeah.
Kristin, I was just with NRCS last week in Washington, and they are trying to produce a biochar dashboard or a 336 dashboard. The information to answer your question is publicly available but not easily accessed.
Yeah.
But NRCS is working on a dashboard to answer that question.
On an average, how much do you get under CBS 336 per ton of biochar?
Sorry, could you repeat that? And maybe into the mic.
Per ton of biochar, how much your farmers will get under CBS 336?
It depends again on the state, right, and what the current rates are. So it can vary anywhere from $200 a cubic yard and up. So, but the way that each state implements it is really different. So each state is allowed to make priorities on what they want to implement, and they go from there. So while the payment schedules will certainly offset the cost of biochar, it's whether or not the NRCS makes that a priority in that state. Anyone else?
Can you just explain the regional differences between what's been approved for the 336? Is it just the state level design that's really driving that? Why are people in California
a good question, and I think it's a really good question for the state con in California more than it is for me. But I think, again,
Need its own guide.
yeah, I mean, again, I think that, each state has priorities on what conservation practices they want to implement. And each state has a different mechanism for applying for funds. So sometimes they get the applications in, and then they decide what practices they're going to fund. And other states do it differently. So they have kind of the opposite, where they decide and then they get the application. So it's a very complex system. I am not NRCS. I am Agricultural Research Service. So this certainly isn't my area of expertise. But again, if you have questions, I'm happy to connect you to the National Division Lead for soil health, who can directly answer your questions, or I can do best to answer them later in the week. But I have the same questions, like why, like, come on, NRCS, let's, make this a priority. But I will say that, there's, cover crop, this is competing with a lot of other conservation practices. There's probably hundreds of conservation practices around cover cropping, around no-till, around high tunnels. Y'all are competing with a lot of practices that farmers have been implementing for a long time. And so when you, and there's also a lot of farmers who are very skeptical about working with the government. I know it's shocking. So a lot of farmers in my region don't even get NRCS funding, whereas if you go to the Midwest, it's very common. So I think it's cropping system specific, it's state specific, and it can even be county specific. My best advice is to call your county planner, talk to your state con, talk to your state agronomist, and find out how you can have them make this a priority.
Will the farmer is allowed to take both CPS 336 and the carbon credits?
So the farmer usually doesn't get a carbon credit, right? So now, whether or not the producer, like if a farmer was producing their own biochar, certainly they could jump into the carbon market and probably stack those benefits. But most farmers are not interested in the carbon market, number one. And number two, it's very difficult. Like, I don't think farmers would be eligible for carbon credits just for applying biochar. That comes at the production stage, not at the application stage. But they can stack these benefits. So for example, if they're doing nutrient management, if they're doing soil health management, if they're doing cover cropping, they can certainly stack those practices and get an application approved for multiple practices at once. Okay, awesome. Thank you so much.